Good morning. This is Professor Grenfell's Math 12 Statistics class. Today we're returning to Chapter 10, Section 2. We're continuing on in Chapter 10, Section 2, I should say. We're going to take a look at Example 10-10. And here it says to find the equation of the regression line for the data in Example 10-5 and graph the line on the scatter plot. And if we flip back, example 10-5 was taking the data from example 10-2 and computing the correlation coefficient. So in this example, in the scenario in 10-2, they were trying to examine to see whether there was a correlation between the number of absences that a student had in a given semester and their final grade in a particular class in that semester. And in that example, we had already copied down all of the values for X, for Y, and then in addition to that, we went in and added in some extra columns in our table. So we had a column for X times Y, we had a column for X squared, and then we had a column for Y squared as well. And we've already done this, I don't know, I think I did it once for one example and I did it over again. I've done it twice at least, and I know you've done the computational part of it. So in this one, I'm not going to refill in those charts and multiply and square and then add all of the things up. I'm just going to go back to my scratch work from this problem and write down what the sums of each one of these are. So here we've got the sums for all of them. The sum of all of the X values is 57. The sum of the Y values, and so on and so forth, are all given there. So this is the formula for A. This is the constant coefficient in the equation for the regression line for Y prime. And we'll substitute in all of these sums that we have above. And then after that, we go ahead and complete that calculation with the calculator. And after rounding to 3 decimal places, I get 102.493. So that is our constant coefficient for A. And then, of course, we'll go ahead and do the same exact thing for B. So I've copied down its formula, n times the sum of X times Y minus the sum of X times the sum of Y is, divided by n times the sum of X squared minus the sum of all of the X's, that whole thing squared. Okay, and so there we have that. That is all substituted in, everything in its place, and according to the calculator, we calculate this gives us negative 3.622. And again, the rounding rule here for our correlation coefficient is we round to 3 decimal places, and all of these coefficients, the A and the B, and Y prime equals A plus BX, are found via these. And we will round to 3 decimal places as well. So here we have, this is A again, and this one is B. And then our final answer to this is going to be to write down an equation. The equation of this line, in this case, is Y prime. So we don't use the symbol just Y itself. Remember, that is the actual data that we go out and collect. The Y prime is our expected value. This is if we don't have this particular X value, we don't actually have a data point, we can substitute the X value in and make a prediction for what the Y value we would estimate what it would be. All right, so here we have this essentially, and our final answer is going to be just substituting in 0.493 in place of A, and then what in place of B? It was negative 3.622. And then it's an equation, so we have both variables in it. We have both the y prime and the x. And so here, this is our final answer. It asks for the equation of a line, and this is the format for what our equation is going to look like. It's going to look like y prime equals something plus, maybe minus, something else times x. And keep in mind, our answer is not complete until we actually go ahead and put in numerical values for both A and B. So that's what we've done here. Now we'll pause for just a brief minute and then go on to example 10-11 so that we will see, what's the point of finding the equation of the regression line. All right, so yeah, here we are at page 568. We're looking at example 10-11, and this is still pertaining all the way back to example 10-2. We saw it again in 10-5. Saw it in the previous example, and now we're treating it again. So we're looking at the relation between absences and final grades. And we've explored this relation via the data that we've gathered and analyzed. And now, in this last example, it says, use the equation of the regression line that we found in example 10-10 to predict the final grade for a student who missed 4 classes. All right, so here, what we're going to be doing, remember that X was the number of absences. And so here, we're going to be substituting in 4 in place of X and figuring out what value do we get for Y prime when we do that, right? And what are we going to substitute X into? What equation are we going to use? We're going to use this one. Y prime is equal to 102. I forget what the decimal was. I have to look back to the previous page. 102.493. And then B was a negative 3.622. So minus 3.622 times X. So this Y prime is going to be the expected value that we would expect if we were substituting X equals 4. So that's exactly what we do here. So, just procedurally speaking, we'll just replace the X with a 4 and do that exact calculation. All right, so substituting everything in and using the calculating device to help us out. And then after rounding, we see that the expected value for Y is 88. So what does this mean? We would predict that if a student has only 4 absences, their final grade would be around 88. Let's do one more example. Let's suppose we want to ask this question. So the question that I want to pose hypothetically, this is often very useful. What grade would we expect for a student who had no absences? And here, we can actually go one step further than saying, well, we expect they would have a good grade. We can actually get a numerical value for that. We've done all of this work now. We've taken the data, we've looked at the scatter plot, we've seen from the scatter plot that it looks as if the data is linearly correlated. We calculated the correlation coefficient. We tested that coefficient to see what significance it had. And now we've built the equation for our regression line. And what the regression line is, what the previous example showed us is it is our way of making a prediction. What we'll do is we'll plug in one variable, we'll plug in the X value, and we'll see what Y value we get out, and that will be our prediction. So here, all we're going to be doing is substituting in, not n, substituting in 0 in place of x, and we'll see again what does the value of y prime equal to when we do that. All right, let's just scroll up a little ways here and recall our formula y prime. So there it is, y prime equals 102.493 minus 3.622x, and there it is, substituting in 0 in place of x, and then without a calculator, this whole part here, that becomes 0, and so what we would get out after rounding, let's say it's 102.5. And notice here, our prediction model, this equation that we are using to make the predictions, is not going to be guaranteed to be 100% accurate. In this case, notice if we have 0 absences, this says we're guaranteed to get above 100%, which, just may not be physically possible. In my class it is, because I offer extra credit. In other classes they may not necessarily. So yeah, we see that the model here is only valid within a small range. If you step too far outside of that range, then it's no longer valid. All right, so that's a summary for Chapter 10, Section 2. We'll stop there and pick up with the next material. Stay tuned until then. Bye.